The straight river is going to continue down the mountain. As it continues down the mountain, it's going to be joined by more and more rivers. It's going to get wider and wider. But over time, it moves further down the mountainside. It's going to also erode more deeply in the landscape. As it erodes more deeply, it's going to sort of start to at some point flatten out. If the river starts to flatten out, it gets to a point where its load is just a little bit higher than when it starts to get closer to its capacity. And when that happens, some of your sediments going to start falling out of suspension here. You're going to start getting these little deposits here. When that happens, that's going to those sediment deposits are going to start to block the river, forcing it to kind of go around them. The river is still trying to find the shortest, steepest route to the ocean. What you're starting to see here, the river's starting to get its own way as the load gets greater than the capacity. And what you'll start to see here is opposite the side of the river where that first little pile of sediment comes out, you'll start seeing some erosion taking place. Now that the river started, and now what's starting to happen here is that because your river is going to be going quite a bit faster on the outside of the bend than it was on the inside of the bend, it's going to be able to erode more as it goes around this curve right here. What you'll start to see, will look a little like, what you'll start to see is on the outside of the bend, you'll start to see erosion. We're going to label that erosional feature. We're going to call it something. We're going to call it a cut bank. We're going to call this deposit, and because it's moving a lot slower on the inside of its curve, water that was originally moving on the faster outside of this curve is going to lose its ability to hold sediment because it's not moving as fast, and you're going to get this sort of deposit called a point bar. Point bar. And the term for a river that's sort of doing this sort of wiggling motion is a not a straight river, but a meandering river. Well, this system, a meandering river. It's still eroding, it's still cutting a little bit in the hillside, but it's into the ground, but now it's sort of not doing as much. You're starting to get these deposits of the point bars and your cut banks. The term for this, you'll spot some of the video I post shortly. You can actually see meanders form naturally. So your channel geometry in a meandering river is going to look a little different. You're going to have usually one very steeply cut bank on one side, then where the water's moving the fastest. Then you're going to have a much more gently sloping part of the river channel on the other side, where the deposits have been the dominant process. Now, we all know that sometimes we get wetter days than others. This is certainly the case here in Southern California, and we even get periodic flooding. So if you have a river that's generally right at about here, you probably notice that most rivers have a flat area alongside them. How is it that we get that sort of flat area just a little bit above the banks of the river? So periodically, your river is going to flood. Here's a little flood level. As the river floods and jumps its bank, you're going to get a lot of sediment deposited right where the channel goes from being fairly deep to where it gets to be a lot shallower. And when the river finally jumps its bank, you're going to get really heavy deposits right there at the edges of the banks. We sometimes call these natural levees. And you're going to get this large area where the river's picked up a bunch of sediment from the main channel and is depositing it on either side. And we call this deposit of heavily worked sediment that on either riverbank, we call it a floodplain. Now, flooding doesn't just sort of create these little flat terraces on either side of the river. The other thing the flooding process does is it can actually cause the river to periodically sort of create a shortcut. During a period of high water, this point bar, not being that tall, can be overtopped. And when it does that, the water is going to start to fall because this is by far the steepest way water to go. Meanwhile, you're going to still get these overbank deposits on either side. Now you still have this abrupt straightening of your river. We call this an oxbow. Let's see what one of these looks like. This is one near where I grew up in Massachusetts. There we go. The oxbow. In fact, they literally called it the oxbow. If you're driving along this freeway right here, you can see a sign for Oxbow Marina. My brother went water skiing there a couple times. I never had friends that took me water skiing, in fact, so I never got to do it. But see a nice little diagram of its evolution right here. Now, cool thing about meandering rivers is that they can actually, because their flow can vary quite a bit, especially in places the flow is highly variable, they kind of have this beautiful fractal quality where you have, like, right down here, you have meanders on a very small scale, but if you look close, you can also see meanders on a much larger scale. And hopefully you can see several cut-off oxbow lakes here in this particular river basin. This is the Yukon River through some part of Canada, or Alaska, I'm guessing, though I wouldn't be able to tell you precisely which part of those respective parts of the world. But sometimes you can get meandering rivers that meander on an even much larger scale. Being that these meanders happen on all scales, and the sinuosity, the tightness of these curves is going to be very much a function of how much water it is, how steep it is, how fast things are flowing. In fact, let's take a look at the video we did from a couple semesters ago. What we're looking at here is a stream table we built in fall of 2019. I want to watch as the flow goes. Oops. This is basically just a giant sandbox. Now watch what happens as the water increases. So first, before we go full on, cut it right at the moment. So you can see beautifully here on the this side of the screen, we have a beautifully marked cut, very distinctive cut bank on the outside. This is generally a steeper face. On the inside of here, we have this sort of deposit. Now watch what happens, this classic point bar deposit. Now what we're about to do in this video is increase the flow rate of the water through the system, creating a sort of a flood. Watch what happens to the course of the river as the flood takes its course. Wait for it. Oh, there it goes. Look at the sediment flux. Whoa. And, see that? We just got a cutoff of the meander here. We still have this oxbow lake marked by the red dye. And now the river's gotten a lot straighter when the flow rate has increased. Now I'm going to post a link. This video will be posted up on the Blackboard page, a fuller version of this video, but or as I've been reminded, if you're using Canvas, it'll be on that site. I'm using this for a lot of sites, but all right. There we go. So this wraps up this portion of the video. For next part of class, we're going to work on other types of river systems. We're going to look at braided rivers and river deltas. And we're going to look at what happens when we put dams on rivers. All right.